Welcome. Welcome to this talk, which is, got all the buzzwords in it. It's got AI, so, that's really hot right now. It's got if you were just up at another AQAvit talk, there's the two talks at the project about, the two talks at a conference about a project I really love, which is Eclipse AQAvit. Under-celebrated, heavy use project, all about developing structure around testing that could be used by multiple people. And Eclipse OpenJ9 as well. So I am a committer on Eclipse OpenJ9, and I'm a project lead on Eclipse AQAvit. And this is kind of the story about how we're doing playful experiments in all the projects so that we can innovate and modernize our tools and look at exploring the use of other tools to make our jobs easier. And I'll say that a lot of the slides here were developed by Lan and Long Yu, who are great colleagues of mine that work at the Eclipse AQAvit and Eclipse OpenJ9 project. I'm presenting them, and I've inserted a few of my own slides that I don't think there'll be any objections to. But what we're going to cover is, first of all, a little bit of what these couple of projects are. The main kind of focus here is why we need AI for our projects, and giving a little explanation of our testing challenge. I do want to explain some of the research that went in to a program that we did recently with Semesters of Code. So there's a few projects that I'm going to cover, not just a single kind of research project that we did. And then some of the ways I think we can leverage some of our learnings and some of the kind of tools that are available to us going forward. But to begin with, I will say, well, Eclipse AQAvit, what is it? It actually is an acronym inside the name, Adoptium Quality Assurance VEAT. And mostly VEAT stands for vitality. How do we actually do quality assurance and keep it vital and useful and have it keep up with the implementation it's meant to test? I'm going to also say what I know the definition of quality assurance to be, which is make quality certain to happen. Oy. You can't test in quality, right? Once something is out there, you can't run a test and make it better. So what's the purpose of quality assurance? Is to be a set of tools that can give the development team and the distribution team something to measure against to say, okay, we have a level of confidence, but also as we're developing, we can be running something easily so that, we're catching those defects before we ship out to consumers. But I also put a link there to, we're maybe one of the only, I think we're the only Adoptium project, it's a sub-project of the top-level project Adoptium that has its own manifesto. That made us sound really kind of cool and renegade. So we created a manifesto, and in it, it mentions this notion of staying current, being vital, and evolving, continuously improving. And that's what these explorations that I'm going to talk about are all about. It's talking and working with researchers. It's looking at new tools that are available to us in the world and seeing, can this help us do our jobs better? But in general, yeah, the 4 blocks across this slide deck, the engage, establish, outreach, and extend, they're kind of written into that manifesto where we don't have a project that just exists to test, Tamarin, this, second most popular JDK distribution in the world, if you follow some of the statistics. It's not just for that. We thought, why would we limit AQAvit to just be for that purpose? Why don't we create a community, shift all the testing stuff left so that all distributors can benefit and all distributors can contribute? Because then we can level up. we can make quality assurance that make quality certain to happen for the entire Java ecosystem instead of just for a singular distributor. And establish kind of a de facto approach to testing. But also this outreach to all consumers at all levels, that's kind of critical. We haven't really achieved that yet, but as I walk around and talk to people at this conference, we know that there's lots of enterprise customers that are depending on very important, maybe they have 5 or 6 Java applications that their business depends on. How can we take that information and understand how they're testing within their companies, bring it to this open initiative, and have our consumers benefit by the actions that we take. And then, of course, in the cloud, right? We want to run a lot of different workloads, and we want to be able to show that Java is there and completely comfortable to be run in a lot of different environments. So a quick note about Eclipse OpenJ9. Of course, Tamarin is a hotspot-based JDK that we produce out of the Adoptium project. Eclipse OpenJ9 is a different kind of JDK, mostly backed by a lot of IBM developers. A lot of them are working in that space. But it's a kind of a neat option for some folks who need very small footprint, very fast startup, and just a slight alternative to what we have over in the hotspot world. I'll say OpenJ9 was first, J9 was first developed to be run on very, with an extremely small footprint. It was developed as a, we were talking over lunch about when I was back in the days when I was working in IBM, I was helping do releases for Java ME, and some of our customers were car companies, telco, and game boxes. So we were running in a lot of different places, and then it's very satisfying to see Mike's keynote today talking about the ubiquity of things running in a lot of different cloud environments, and the need for us to be able to make sure quality happens in all of those new places where we're running software. But I'm going to come to the testing challenges now. And this is a very dated slide that I created many, many years ago. So mind that we're at JDK 23.0.1 as of this October CPU. So that versions line could be updated, but we still deliver the LTSs 8, 11, 17, 21, plus 23, plus tip, which is 24. So we're at any given time at our project, we're running that across a whole whack of different platforms, across several different JDK distributions, in fact. Although our focus at Adoptium is testing Tamarin, we maintain the ability to test all these other distributions, and in fact, many of our Adoptium working group members use AQAvit to test their distributions before they push their distributions into the Adoptium marketplace. But having said all of that, the real number there is how many tests we run and how much test output there would be on any given EA build or GA build. A lot of stuff to go through, not really humanly possible, so how can we do this in a better way, leveraging some AI or leveraging other techniques to make it less onerous for humans and more successful for the project. So come in, IBM has the Center for Advanced Studies project, and this is where we had done, or AQAvit had done work with Professor Udine out of, I guess now he's at York University in Toronto, Canada, and 2 grad students, Afif and Tamana, who essentially looked at OpenJ9 issues as the exemplar of here's a very, very, very large project, very complex project in the open with a lot of different committers, and the software itself that is being built under there, just like hotspot distribution up in the OpenJDK repo, has a lot of different components. There are you know, JIT team, GC team, VM team. There's a lot of different people working in that space. And what that this research project did was actually assess how could we automate certain things, how could we train a model to make some of this kind of project management a little easier. There was actually a lot of spin-off research that came out of this, but I guess the short story here is we broke it out into several kind of outcomes. Could we look at scan open issues, refine the data, and predict what component the issue should be assigned to or labeled as, what developer would be the right developer to assign the issue to, and then whether or not this issue was similar to other things in the... So yes, you could do it, humans could do this, but humans wouldn't want to do this on a day-to-day basis. In comes our semester of code project, and there's a little video at the end that'll describe this better than I'll do right now. But if you saw the talk this morning by Stephen Wally around this program that's being developed, it's very much similar to a couple of other open source programs we've participated in, where you have a group of students from a university. This is part of a class that they're being taught there. So they have a dedicated amount of hours that they are able to work on your open source project with. And we decided we would take that research from the CAS project, pure research, not really implement it, and say, could you take this research and could we deploy this research in production in an actual open source repository? So that's almost as specific as we were in our project description to the students. So the way we had to do it is you describe your project and then you hope a student team will pick you. It's kind of a funny model. But of course, AI was in the title, so this was one of the projects that they immediately picked. Myself, Lan and Long Yu were the mentors on this project, and we had 5 students from Carnegie Mellon University, based out of Qatar campus, and they were just a wonderful set of students. Anyway, they were kind of given this, they were given very loose guidelines around, let's see if we could create a workflow. Wanted this to be cheap, didn't want to spend a whole lot of money or resources on a whole lot of different infrastructure. So, but could we take that model that had been developed by the research students out of York University under Professor Udine, and could we deploy it in a functional way at OpenJ9? And we picked that because that's where the model was trained. Of course, now we know we can deploy it elsewhere, but they were the guinea pig. And so essentially, I'm going to kind of step through it here because this is a bit of a better description. The way the workflow ended up working, what the students actually ended up developing was when a new issue is created, could that creation of the issue trigger the model to say, oh, now I'm going to try to categorize this into what component I predict that this should belong under, and who is the best person to assign this to. And yeah, if you have a really small team and there's only 4 people, it's probably going to be the same names anyway. But that's partly why we chose the OpenJ9 project as the example as well, because we wanted it to be a little bit more complex and a little bit harder to predict. So you can see now that when an issue gets opened, automatically, the very first implementation of this was, let's not assign it to a developer and make them mad because we're generating a lot of noise. Let's just shoot it to a Slack, a channel that no one's watching right now, and just check that this is working as we expect. So that was the initial run of this. I'm going to come back one more step because I'm going to quickly talk, before I return to that project, I'm going to quickly talk about something we also did, which was called Deep Aquatic. Same notion. We have a tool that can monitor multiple Jenkins servers where we run tests. So we gather tests from vast locations, and you saw those, up to 87 million tests a night. Gather them and summarize them in a tool we call TRSS, or Test Results Summary Service. Could we kind of also have a way that we said, analyze this test failure and tell me if it was similar to is this the same failure as we've already seen? Is there an issue already open for this? And train a model to connect it to that issue, but also have this interface where humans could go, yeah, it's definitely not that issue, sad face. And so we can keep training that model and make it get better based on human feedback. So this is kind of what that looked like. So remember, we had those three things. Predict the component, figure out who's the right person to assign it to, and then also figure out, before raising a new issue automatically, don't do that because we don't want that glut. If there's already a good issue that it's the same as or very, very similar to, let's flag that. And this is a messy description, but this is kind of how that Deep Aquatic project worked. It was actually done through the Outreachy program, which is a bit of a heavy lift. Outreachy is an open source program where you get help from participants who maybe have never done software development before. So a lot of mentor time to be able to drive something like this forward, a much slower turnaround on results when you're working under that kind of program. Okay, well, so I've got this future work slide here. It maybe should have belonged at the end of the thing, but there's actually a longer list of future work than this. One of the next very immediate steps we want to do is say, could we fully automate our triage process? In fact, could we get to the point that certain types of failures we generate a fix for and say, okay, we think this pull request is going to actually be the next best action that happens based on what we've just witnessed or what the model just witnessed. We do want to collect more experimental data to improve these model performance. Part of the work that Afif and Tamana did was actually personally interview a bunch of developers as well. And so this is an interesting one, and maybe one that doesn't happen so much in other trainings or other development of models, but Professor Udine was very clear that he wanted to make sure that he did this. Talk directly to humans about how they work in open source repositories. And so when they're looking at, assess the contents of a particular GitHub issue and see who's active and making comments in that issue, what's going through their mind as that's happening? What roles do they think they're playing as that's happening? So a lot of interviews actually took place in the development of the Triager X model, and I should say that's kind of the model we're talking about when we talk about the semesters of code project. It's called Triager X. I don't think it was on that initial slide because we were holding back of sharing it until those grad students actually submitted some papers. We didn't want to get in the way of that. I believe it's okay for me to call it that now. And how can we expand the AI tools to other software domains? So again, I'm going to say in this particular examples that we're talking about, one of our focus area was about categorization, automating triage, but where else could we or should we apply AI for our projects? Some of the things we've kind of looked at in past and or prototypes or are interested in taking further and maybe where we can apply certain types of AI, would be, could I generate tests? Could I have a model look at some code and actually generate tests? And I don't mean just generate stubs. I mean figure out what's the right input to pass into a test case so that you have very high functional coverage. So watch how the variables interact within a test method, within a code block, and then create a test method that would give you a very high functional coverage. Find and predict defects. So we started a different CAS project a few years ago that actually read snippets of Java code in open source GitHub repos and generated fuzz tests. This one we couldn't move forward on because we kind of lost our grad student. But at some point I would like to come back to that notion to say, writing, especially generational fuzzers, is a lot of human effort. So yes, it's a very good thing to do, and yes, we would want to do that to find a particular types of defects. And probably it also helps us figure out if we have vulnerabilities, security vulnerabilities in code. But to do it for humans to do such a task can take weeks or months. And there's a great example that Professor Leather and his student, when we did work with them, they'd already done this for OpenCL, where they were able to show that instead of weeks or months, they could generate very adequately good fuzzers in a matter of days using this kind of model. Bug prediction, there's a lot of prototyping that we had done on this before, and I don't know that I reference it in the back of these slides, but Google had also done some really great research around predicting where bugs live in source code. Again, this is another place where we could just apply some automation, and maybe some of that automation could be artificially intelligent automation. Predict performance. This one is interesting too. A lot of you would run performance tests, but could you train a model to actually look at code changes and predict that, hey, we predict this would be result in very poor performance. All right, so I'm going to get to the end of this because I'm going to finish with kind of an exciting little video. But the kind of final thing is why we need AI for projects is we need to learn new things. We can't go stale with our knowledge and what we know, and we need to have fun while we're doing it. So now I want to take you here to say, we challenged that Semesters of Code team to produce a video that was like an elevator pitch. We said, a lot of the work you do, or you will do as you go into your career as a software developer, is convince your management team or your executive team to fund new stuff. So you have to be able to explain what the thing is you're doing in a compelling way so they want to fund it more and give you support. So this is what they came up with.
Picture this. It's a hectic Monday morning, and you're the lead software developer. Just as you're diving into your tasks, a big number of bug reports floods your GitHub repo. Sorting and assigning these issues manually takes a lot of time and can be incredibly frustrating. But what if there was a smarter way to handle it?
Sure, there is. We all been there. Countless issues popping up on GitHub. Say, when a new issue is opened, you'd like to have a tool that does the work of triaging for you. That's where our project triage is helpful. It revolutionized how we handle the GitHub issues. And here is how it works. When a new issue is opened, it triggers a GitHub workflow, which calls the AI model to analyze and assign the right person to it. This AI model was developed by Dr. Udin and Afif from the IBM Center for Advanced Studies. triage also recommends components for the newly opened issue. You can think of a component as a category of the issue that is related to a specific team at Openj9 organization. When the assigned developers finish working on the issue and close it in the repo, it triggers another workflow that collects the actual assignees and peer authors and sends a new comment to a special triage sandbox issue for evaluation purposes.
This is really awesome. But wait, what happens if the triager X model is down and does not respond?
Good question, and rest assured that we did not forget about it. Whenever the triager X server does not respond, the workflow reports this behavior in the comments to inform the developers about the failure. This failure means that we did not get recommendation for a particular issue. And to address this problem, we have added an option to manually trigger the triager workflows with a special comment that starts with the triager followed by the link of an issue. This only works when the triager is up and running to accommodate for the missed recommendations during the server failure.
Wow, this is impressive. So in short, it's like having a personal assistant for your GitHub issues. No more manual tracking, just efficient, automated task management. Okay, now let's move on to our next project. Next up, we developed a tool that turns Slack into a super-powered communication hub. Oftentimes, a developer, be it a newbie or a senior, can spend a lot of time to understand the bug and prioritize which bugs to fix first. This inefficiency affects open source products since thousands of other third-party tools are at risks because of these unhandled bugs. As such, according to statistics, about 80% of the developer's time is spent on debugging. While debugging, developers first need to identify and understand the issue, which can be buried under countless other tasks. Is there a way to deal with this?
Oh yes, there is. This is what our second tool is all about. Slack being the main communication channel for Eclipse Adoptium developers, we've created a chatbot that can be integrated into Slack. The chatbot provides an interface of several commands, such as summarize, interact, and recommend. Under the hood, it uses 3 large language models, Llama 3, ChatGPT, and Gemini for communication, and a classification model triager for recommendation. Let's look at the way it works. First, let's try to get a summary from Llama 3 for the issue. We need to use the following command: @chatbot/summarize -llama3 and the link of the issue. Okay, we got the response. It seems like the issue is about java.lang.nullPointer exception that occurs in the Unicode casing test class. What is cool is that it even provides potential recommended steps for debugging.
Next, we can interact with the large language model to further understand an issue or ask any questions related to the Openj9 repository. Just for fun, let's ask Gemini to turn the summary into a Shakespearean poem. For this, we need to type the following. First, we mention chatbot, ask it to interact, and we choose Gemini as the model. Then we propose our question, which is, can you please write a poem about the summary of the issue provided in the previous message? Great! It responded with a very beautiful poem. Now, let's prompt ChatGPT to tell the difference between the 2 previous messages. Again, we'll mention chatbot, ask it to interact, select ChatGPT, and this time, our prompt is going to be, please tell the difference between the 2 previous messages. Lastly, we can even double-check the issue recommendation by triager in Slack chat. This avoids extra comments in GitHub. Again, we mentioned chatbot, but this time we ask it to recommend using the triager model, and we provide the link of the issue from GitHub.
Perfect. That's super convenient. Instead of wasting time figuring it out, your chatbot gives you a head start. It's a great tool for developers who want to hit the ground running. It not only saves time, but also boosts productivity by allowing developers to focus on what they do best, coding and solving problems. By any chance, do developers get notified when their team gets recommended to resolve a new issue?
You guessed it right. After getting the response from triager, the workflow sends a request to our Slack chat bot to mention the channel of the recommended team. You can see the notification here on the screen. And how the team has already started working on the issue.
Wow, that's quick. Good work. Given the great progress that you have made, what do you plan to do next? Tell us more about the future of this project.
Well, there is still work to be done. I say this because in the past few days we've been exploring ways to improve the current triage model by examining different machine learning pipelines and fine-tuning existing models to mimic its performance. As you can understand, one of our main goals was to improve the accuracy of triage model, as our analysis revealed that the current model needs to be retrained with a larger and more comprehensive dataset to ensure that it incorporates all necessary information. On top of that, we also thought of an idea that automating the training process to keep the model up to date, similar to how these new AI models are being developed, should be a priority. This will be an important focus for future work, and we presume that once all is done, triage will become a highly efficient and reliable tool for managing bug reports, not only in Eclipse Adoptium projects or Eclipse Foundation projects, but also for other software development companies and organizations.
So, the focus is on the intersection between industry and research work. Exciting! Alright, guys, you've seen both projects, TriagerX GitHub workflows and the Slack chatbot. You've also heard about the future direction of this epic project. If you are interested in contributing to this project, consider joining the Eclipse Adoptium team. Now, time for the big question. Which one will change the game for developers? Comment below and let us know. Thank you, guys.
All right. So many people involved and so fun. All right, so I think that nearly closes the talk, but I do want to say I thought that they had done, what was most gratifying about that work was, one, they actually were able to convert something that was kind of pure research into something that we could deploy. And they did it in a kind of short amount of time, because it was a 4-month term, and while Stephen had said in that talk it's 40 hours a week, only about 8 hours of that time was really programming time. They had a lot of classroom kind of theory stuff that they were covering under that class. But what we saw really was how excited the team got around a really good, fun, juicy project, and how much they kind of, they were even, that video, someone hand colored in the talking mouths. Like, they were really dedicated and wonderful to work with. So I don't know if people have questions, but I also think I might be 48 seconds left. So please ask if you have. I may or may not be able to answer. I think that's what we've got. So thank you. Yep. Great. Any questions, or we're good to head over to Committer Central? Hey, by the way, how many here are committers in projects? I know you are. Any other committers in? Yeah. So if you didn't submit or haven't yet kind of submitted to that Semesters of Code, I know Stephen is going to be doing it again, and I highly recommend it as not a whole lot of effort on the mentor side per what you get out of the team that's working with. So strongly recommend participating in that project. You can really get a lot of stuff done, and it's a lot of fun and very energizing. Great, thank you very much. Okay, bye.